All right, I hope everybody's having a great evening. This is our final video before our quiz tomorrow. Make sure that you're getting some review examples in and that your review of exponents is going well. For tonight's video, we've got 4 of your classmates here to volunteer and give some advice and some help. So go ahead and say hi, guys.
Hi.
All right, we've got Reagan, Ellery, Barrett, and Towns. So our first example that we're going to look at is the quantity of 3x squared y to the negative third z all to the third times x to the fifth y squared all to the negative second. Any ideas how we want to start this? Okay, Reagan?
You do the 3, and you have to do it to the cubed.
Do it to the cubed. Okay.
I didn't mean it like that.
So you're right. We have to take this 3 on the outside of the parentheses and make sure that it goes on every single term. So it becomes 3 to the third, x to the what?
6th.
Thank you. X to the 6th, y to the negative 9th, and then z to the third. Good. Barrett's all over it. Barrett, what do we do with the next part?
All right. Well, you have to move it down since it's a negative exponent.
Okay.
So it'd be that all over x to the 5th, y to the 2nd, to the power of 2.
Good. So we still want to keep it in the parentheses. Just move it down here, and now it becomes to a power of positive 2. That's one way to start this. Any ideas from here?
Is it all to the negative, or to the 2?
Yeah, when we move it down, it all is raised to the second power here. Good question. No, just the bottom. Just the denominator here.
Can you, like, times everything by the 2?
All right, we don't necessarily multiply everything by that 2, but yeah, we take that 2 into everything in these parentheses. So, Jordan, welcome. We're recording here. We've got 3 to the third, x to the 6th, still y to the negative 9th, z to the third, all over. And what's this become, Towns?
X to the 10th, y to the 4th.
Very good. X to the 10th, y to the 4th. All right, any ideas how we can move from here? Ellery?
You combine the like terms.
What terms can we combine?
The 2 y's and then, yeah.
All right, so let's take a look at the y's. This one's a y to the negative 9th, this one's a y to the 4th. Any ideas?
You would subtract.
We could subtract, and you do negative 9 minus 4, which gives us what? Negative 9 minus 4?
Would be negative.
Negative 13. So that's one way of doing it. Y to the negative 9 minus 4, which gives us y to the negative 13, which if it's to a negative exponent, that tells us we move it down. Okay, that's one way of looking at it. Or you can also look at it from the beginning. Y to the negative 9th by itself could get moved down to the denominator and become y to the 4th times y to the 9th, which again would be y to the 13th down in the denominator. So, in the numerator, we still have 3 to the third, we still have an x to the 6th, and a z cubed. In the denominator, we now have x to the 10th and y to the 13th. What about from here?
Why did the x to the 10th go to the bottom?
Well, the x to the 10th is in the bottom after we had the x to the 5th squared. That was already in the bottom.
Oh, okay.
But what can we do from here?
Combine the x's.
All right, combine the x's. What do you mean by that? What's it go to? What do the x's go to?
4.
X to the 4th where? In the numerator or denominator?
On the denominator.
Good, good. So 3 to the third, guys, is 27. The x to the 6th and x to the 10th, as Barrett told us, becomes an x to the 4th in our denominator. We have a z cubed in the numerator and a y to the 13th. All right, let's just do one more example. Last example with our helpers today. We've got the quantity of a to the third b all over ab to the negative 2nd, all raised to the negative 3rd. Any ideas on how to start this one? Anybody?
You make the negative 3rd positive?
Make the negative 3rd positive? How? You're right, that's not a bad idea, but how do we change this negative 3 to a positive 3? What?
Move it to the bottom.
Well, we don't just move the 3. We can't really move an exponent.
Would you move ab to the negative 2nd up and then a third to the b down?
Say that again.
Okay. You'd move AB to the negative 2nd up and then a third to the b down.
Good, exactly. We just switch everything in here. If you change the sign of the exponent, you make sure that you just switch or find the reciprocal of the fraction. Remember, negative exponents are reciprocals.
Does the -2 on the bottom become positive up top?
It doesn't. That's another great question. Not yet, because when we moved it up, it wasn't using the -2. It's because we had changed the -3 to a +3. Very good question. Ellery?
Do you multiply the top and the bottom by the exponent?
Okay, now that's a good way to go. She's asking, do we multiply the top and the bottom by this exponent? Anybody have an answer?
Just the top.
Just the top? But it's all in parentheses.
I think both.
I think both.
I think both.
We we also multiply the top and bottom. So it becomes a to the third, b to the,
Third.
not third,
Oh,
and then top here.
-6.
Good, -6. Barrett's looking at this upside down, so it's tough. All over a to the 9th, b to the third. Very good. Now what can we do? We're almost there.
You can simplify it.
Simplify what, Jordan? Okay, the a's.
So you had to subtract, I guess?
You could subtract, and you can do a to the 3 minus 9, which gives us -6. And that just tells us that there's 6 powers of a down here. How I look at it, guys, from the beginning is if there's 9 powers of a in the bottom, 3 powers of a at top, they go to war, who's going to win?
The 9.
The 9, and they're going to have 3 casualties, though. Okay, so there's going to be only 6 of them left over. What about the b's? This is a -6, and this is a 3. You can do the subtraction rule if you like that. -6 minus 3
-9.
Would be
would be -9.
So it'd all be on the bottom.
So it's all on the bottom. You've got it. And it
That is
becomes b to the 9th. 1 over a to the 6th, b to the 9th. So those are 2 quick examples with our helpers. Guys, say see you later.
Goodbye.
Good day.
Thanks for helping. All right, well, we're now going to take a look at 2 more examples. So I'll come on down here. We have 4x to the -3rd y, z to the 5th, divided by 6x, y to the 4th, z squared. The first thing with this example that I'm going to look at is taking care of this negative exponent. We have x to the -3rd, so I'm going to go ahead and take care of this negative exponent by moving it down to the denominator. We still have a 4, a y, and a z to the 5th in my numerator. Down in the denominator now we have a 6. We have the original x that was here. I'll go ahead and place this x to the -3rd down, and it becomes x to the 3rd in my denominator. We have y to the 4th and z squared. Now, moving forward, we have 4 over 6, so we can simplify that just like the fraction 4/6. That simplifies down to 2/3. We have 1 factor of y in my numerator. We have 4 factors of y in the denominator, so the subtraction rule would tell us y to the 1st minus 4, or y to our -3rd, that's our quotient property, or we just know that there are 3 factors of y down here. Also, looking at the x's, there's 1 factor here, 3 factors here, so we have x to the 4th, and we have y to the 3rd down in our denominator. And moving on to z's, there's 5 factors of z up here, 2 factors of z here, so we have z to the 3rd, and that would be my final answer. 2z to the 3rd divided by 3, x to the 4th, y to the 3rd. Okay, doing a couple steps at once. The last one's pretty challenging. We've got 2 different exponential expressions here with fractions. First one, 3x to the 5th, y to the -3rd. What I'm going to do is take care of that negative exponent by moving it down first. So we'll have 1 over, we still have 4x to the -2nd, times 3x to the 5th, y. Now it's going to be raised to the +3rd. Multiplying this by 3x to the 2nd, and the 6y to the -2nd can be moved up to the top, becomes 6y to the +2nd. So we took care of some negative exponents. Now moving forward from here, this x to the -2nd is the only thing that's being raised to a negative power, so we can move that up or back up to the numerator, so it becomes x squared. We have 4 times, this would become 3 to the 3rd, x to the 15th, and y to the 3rd, and we're multiplying that by 3x squared times 36y squared. Took care of this 6y quantity squared. Alright, moving forward from here, we can now look at this with my numerator. Remember, this is all over 1, so we can multiply and combine some powers here. Everything is being multiplied. we have the 3 times 36, still, I'll leave that out in front, 3 times 36. X squared times x squared gives us x to the 4th, and we have y squared still on the top. Down in our denominator, that's 4 times 3 to the 3rd. So we can make that 3 to the 3rd times 4 times x to the 15th times y squared. Again, everything here is being multiplied, just like in all the problems. So to finish this one up, we have 1 factor of 3 up here. We have 3 factors of 3 down here. So this 3 cancels with this. We're left with 2 factors of 3. And then 36 divided by 4 is 9. And actually 2 factors of 3 will give us 9. So sorry, I'm doing a lot here at once. Let me slow it down. This will become 36 in the top. X to the 4th up here and x to the 15th down here. We still have our 3 squared times 4. This becomes x to the 11th, and then the y's cancel. So moving this forward, we're actually left with 1 over x to the 11th. And if you have some questions as to how we got to this last step, make sure you come in and have those questions prepared to ask in class. Hope you guys are doing well and getting ready for that quiz tomorrow. Good luck.